All right, good morning. It is Tuesday, April 28th. Yesterday we talked about writing equations, where either you're given the name and you have to write out the formulas or the formulas in the name. Today we're going to talk about the types of reactions that go along with it. You have 5 types of reactions that we're going to talk about. It's synthesis, decomposition, single replacement, double replacement, and combustion. So the first one we're going to talk about is synthesis. This is a building reaction. So basically you're taking 2 different things and combining it to make one. So for example, you have carbon plus oxygen. And remember, diatomic elements always have a 2 behind them. And I know some of y'all were forgetting the diatomic elements yesterday. Just remember it's hydrogen, which is in the top left corner of the periodic table. And then you start over at nitrogen, which is element number 7. And then oxygen, fluorine, and then go straight down, chlorine, bromine, iodine. Remember, it makes a 7. So anyway, you have carbon plus oxygen yields carbon dioxide. And then you have hydrogen plus oxygen yields water. All right, so let's look at a couple of them. So sodium is Na, and oxygen again is diatomic, is O2. If I'm combining these 2 together, I'm putting them together. So still, this is a metal, this is a non-metal. Use your ion list. Sodium has a +1 charge. Oxygen has a -2. So when you combine it, just remember +1, -2. Remember that 2 switches over. So you end up with Na2O. And all it is right here with the name is sodium oxide. All right, then you have magnesium plus fluorine. Magnesium is Mg. Fluorine is F2 because it is a diatomic element. If you look back at your ion list, because this is a metal, Mg has a +2 charge, fluorine has a -1. Remember, this 2 has nothing to do with switching. So you end up with MgF2. But just remember that 2 has nothing to do with this 2. So whenever you write this out as a word, it's magnesium fluoride. And this is just basically showing you how you'd write them out and all. Whenever I give you examples or a quiz on this, I'm going to already have it written out. You just may have to write like the symbols, or you may have to write the words, but you've got to tell me what type of reaction it is. I'm not going to really have you do this part right here. I'm just showing it to you. So anyway, remember, synthesis, building, take 2 things, makes 1. All right, the next one we have is decomposition. And just think about the word itself. Decomposition means to break it down. Think about when things decompose. Heat and electricity help with decomposition. So you start with one thing and you break it down. So for example, you have sodium chloride, which breaks down to sodium plus chlorine. And then you have hydrogen peroxide, which breaks down to water and oxygen. So with practice, all of these are being broken down by either heat or electricity. So you have mercury 2 oxide. Remember, mercury 2 doesn't have a number behind it. So whenever I break it down, I'm just breaking it down into mercury and oxygen. Remember, oxygen's diatomic, so it has a 2. Water is just broken down into hydrogen and oxygen, diatomic elements. Silver oxide is broken down into silver and oxygen. And then copper 2 chloride, remember that 2 right there goes with copper. So if I was to write this out, I'd have to write copper 2 chloride. Breaks down into copper and chlorine. Remember, when these are written by themselves, they're just like whatever it is on the periodic table. So oxygen, chlorine, fluorine, so forth. Don't put oxide, don't put chloride, or anything like that. All right, single replacement. or displacement. It's also called single replacement reactions. Basically, you have a single element and you're replacing it with the element in another compound. So for example, you have zinc plus HCl, and technically this would be hydrochloric acid. Anyway, the zinc takes the place of the hydrogen. So if you notice, zinc is now with zinc chloride, and then hydrogen is by itself. This one, you have iron 3 oxide plus aluminum. Aluminum takes the place of iron. So these two right here are switching places. So now it's aluminum oxide plus iron. Same thing with copper 2 chloride plus fluorine. In this one, because these are both nonmetals, that's what's switching places. All right, so you have zinc plus lead 2 nitrate. So all it's doing is this and this are switching places. Remember, zinc has a plus 2 charge. So now it's lead plus, and zinc takes place over here. Since zinc has a plus 2 charge, basically this stays the same. All right, aluminum plus mercury acetate, mercury 2 acetate, because there's not a 2 right there. So aluminum and mercury switch places. The thing you have to remember here, mercury has a plus 2 charge, aluminum has a plus 3. So whenever you switch them, that 3 now has to go over here. So I have mercury plus aluminum. And since aluminum's plus 3, this is -1, that 3 goes behind here. You have to make sure you do correct ionic bonding. All right, with this one, again, you have aluminum, which is a plus 3. This is nickel sulfate. Nickel has more than one charge, so since sulfate's charge is -2, nickel has to be +2. So this is technically nickel 2 sulfate. So when you switch them out, nickel comes over by itself. Aluminum now goes with sulfate. So since sulfate has a -2 charge, that 2 goes behind it. And then you have SO4. That 3 now goes with it. So remember, put parentheses and 3. And then the last one, you have sodium plus water. So basically with that one, you're going to make sodium hydroxide plus O2. And again, I would give them, this one's a little bit different. Excuse me, I just messed up on that one. Gives you sodium oxide plus H2. So the only thing that comes over is the oxygen. All right, then you have double. So single is one element, double you have 2 compounds. So this one, basically in this and this are switching places. Zinc and silver are switching places. You got to remember though that you use ionic bonding. So in this one, lead is a 2. So whenever you switch it over, it's lead 2 sulfate, but they cancel out. So down here at the bottom, you have silver nitrate plus NaCl. All of these have a 1 charge. So the only thing that's happening is silver and sodium are switching places. So it ends up being silver chloride plus sodium nitrate. In this one, magnesium and potassium are switching places. Remember, magnesium has a plus 2 charge because of that right there. Potassium has a plus 1. So in this one, you have Mg, and because it has that 2, the 2 now goes with the OH. Remember parentheses, because if not, you're telling me that you only have 2 hydrogen if you don't put that parentheses. And then potassium nitrate. And then the last one, you have Li and you have iron. This is iron 3. So that 3 comes with the iron. So LiNO3. And then whenever you switch over to this one, you have iron. Remember, this has a -1 charge, so the 3 now goes with OH. Okay. And then your last type is combustion. Just think about combustion as explosions, so it's burning. It's an oxidation reaction, so whenever you add oxygen to it, is whenever it combusts. This one, you'll use your carbon molecules. So like CH4 is methane, C3H8 is propane. Remember, methane, ethane, propane, butane, so forth. You always have the products of CO2 plus H2O. So if you see anything like this, that is a combustion reaction. So this one, practice is pretty easy. All you're going to do is add CO2 plus H2O. Okay, so those are the 5 types of reactions that you have. I'm going to give you some practice problems on them just for you to be able to tell me what type of reactions they are. Again, if you have questions, email me, send me a message through Remind, and hope you have a great rest of the day, and I'll talk to you later.